Hi everyone, I'm Ryan Hickox. I'm an associate professor of physics and astronomy here. I'm an astronomer, and I'm running the Colloquium series this term for those of you who are, I know we see some faces we don't normally see at these because I think this is a topic of great interest. So we're doing, for the colloquia this term, we're doing a faculty search in astronomy, so there are going to be a lot of astronomy talks, astronomy research talks later this term, and so we thought that it would be nice to have some talks that provided sort of a different kind of societal or historical context for astronomy. And so just as an advertisement, next week we have James Lowenthal, who's the Vice President of the American Astronomical Society from Smith College, who's going to talk to us about astronomy, light pollution, and the environment. So that's also, he's great, so that's that'll be a really good topic. But today, I'm delighted to introduce Professor Rich Kremer from here at Dartmouth, who's going to tell us about Dartmouth and Shattuck Observatory and the history associated with research here in this small college setting in the historical context. And this is particularly, as you probably have guessed, the reason we're scheduling this term is because there are plans that have been made public that would potentially impact Shattuck Observatory and the College Park area here in general. And so we think as a department that we should make clear to everybody what the actual historic and scientific importance of that observatory is. So I'm delighted to see a number of people here who are not in our department, and of course this is going to be videotaped too, so we can post it everywhere. So anyway, without further ado, Professor Kremer is professor of history, I guess, here at Dartmouth, who has recently retired and is now splitting his time between here and Berlin. But he was an undergraduate at Goshen College in Indiana, and then he went to Harvard for his PhD. In his research here, he has focused on the history of science, in particular science in Europe from the, I think it was the 15th to the 18th century. And then also the history of scientific instrumentation, which is particularly interesting with, relating to Shattuck. So that's enough introduction, I hope.
Okay.
I'll leave it there and just say thank you very much to Rich, and take it away.
Very good. Well, thank you very much. I usually have to get in a plane to go give a colloquium, so it's really nice just to be able to walk across campus to give a colloquium. So how many of you have been in Shattuck Observatory, in the building? I'm just curious. Okay, and how many of you looked through a telescope at Dartmouth, up in the sky? It doesn't have to be the Shattuck one, but any telescope. Okay. Very good. Well, it's good to know, sort of situate the audience here. So I am not going to talk about the future. I'm going to talk about the past. So if you're here to hear what I have to think about what's happening with the College Park, that's not the purpose of this talk. I'm a historian, and I'm going to be looking backwards. So I'm going to tell you a story with 5 chapters in it. And I better take off my watch here so I can see how we're doing with the time. So I'm going to start by talking about actually before 1848 and talk about to situate Shattuck Observatory in the history of Dartmouth College. So we'll look at science, the place of science, and the identity aspects of what science meant for the college in its first 75 years. Then we'll look at the observatory movement, which is the context all across the world. Observatories started coming together for interesting reasons, and Dartmouth is going to be part of that. And then in the 3rd chapter, we'll focus on the events that led to the creation of Shattuck.
We'll get the lights back up.
I don't care, it can be in the dark. That's fine.
That's what we do. Thanks.
Then in the 4th chapter, we'll look at about the 40-year period where Shattuck was on the cutting edge of doing important astronomical research. And then we'll look at the significance of Shattuck for Dartmouth and Dartmouth's identity since 1906. I should say that a lot of this research I did about 10 years ago when with several colleagues we wrote a book on the history of scientific instruments at Dartmouth. I have it in my briefcase, I forgot to bring it along. But we did a book in 2005 that included a section on Shattuck Observatory. And so that's been where most of this research was done. But then more recently, I've spent some time in the archives and have found some new things. And Allison Gelman, is Allison here? There's Allison. Allison is my presidential scholar last year, and she has a wonderful nose in the archives. And so some of this is material that she found as well in her researches. So that's where we're going to go. If you have questions along the way, feel free to jump in, but we'll have time for questions also at the end. So, what was the place of science when Dartmouth was created? How important was science for Dartmouth? I say a small college in the woods, and I mean in the woods. If you read accounts of the first months and years when Dartmouth was being created here, 1769, 1770, there were 200-foot pine trees, all up and down the Connecticut Valley. And the first year, the students basically spent their time cutting down trees. They would get up at 5:30 in the morning and go to chapel. Then they'd have breakfast, and maybe classes till 9 o'clock, and then they'd cut down trees, literally, to make Hanover, because there was nothing there. So this was a small college in the woods, extremely isolated, as was the case with all colleges in North America at this time. The curriculum was prescribed. Everybody took exactly the same thing. All freshmen took the same classes. All sophomores took the same classes. There were no electives for the first 100 years of Dartmouth. So a prescribed curriculum, so we know exactly what was being taught. To get into Dartmouth, you needed to know Greek and Latin and the fundamental rules of arithmetic. So that was the only expectation in terms of your science background that you had. You had to have good moral character and a bond of $300. There was no SAT test, of course. You simply, your father brought you to the president's office, and he opened the Bible, the Greek Bible, and could you read a little bit of the Greek Bible? And he gave you a Roman poem, and you had to read the Latin, and if you could do that, and your father could post the $300, you could get into Dartmouth. Very local. These students came from Vermont and New Hampshire. That's all. This was a very local school. So what did you study? Well, the freshmen studied Latin and Greek. They studied arithmetic. The sophomores, Latin and Greek again. And there you had quite a bit of mathematics and science. You had geometry, trigonometry, algebra, conic sections, surveying, and mensuration. And this was very important. For the first 100 years, every Dartmouth student studied surveying. And that's not an accident, right? You've got a continent out there that's being mapped and being divided. Towns are being made. And even though the purpose of Dartmouth was to train clergy, even clergy needed to know how to survey. Everybody needed to know how to survey. If you were a man in America, you needed to know how to deal with drawing these property lines. So that was pretty the heavy duty. Then in the third year, the juniors, again, Latin and Greek. And there you'd have more mathematics, but there you'd have a course in astronomy and a course in natural philosophy. The discipline of physics wasn't invented until about 1850, 1855. I think it first appears at Dartmouth in 1850. Before that time, you studied natural philosophy, which was broader than physics. It included some chemistry. It included what we now call earth science. It included a big dose of natural theology, which is where you look at nature to learn about God. That was wrapped together in this course, and that was this was sort of the closest to what you'd have as physics. Then the senior was doing theology and politics, Hebrew, and no science there. And the point was there was no innovation. Dartmouth was doing what everybody else did. That's the kind of science you learned when you came. All these early colleges also had what I call an educational infrastructure. You needed the building, you needed students, you needed a couple of professors, and you needed a few other things. You needed a museum, you needed the library, and you needed what was called a philosophical cabinet. And Dartmouth created those three things very early. So this is the first object that came into Dartmouth Museum. It has the accession number 1772, Object 1. It's still in the collection. This is about 6 inches tall. This is a mastodon molar that a person in the class of 1771, one of the first graduates, clergyman, was going out to try to Christianize the Indians in, where is Bone Lick? I think that's in Ohio. And he was out there, and there was a big salt place there where mastodons were. And he found this, and he sent it back to the college for its museum. The college didn't have a museum, but this thing came in, and they started a museum. And the museum was just a collection of weird things. So there was a brick from the Bastille, and there was a coin from India, and there was an abacus from China, and there was bones from something else. And one of the favorite things the students had, there was the skin of a zebra that somebody sent. And this museum was in Dartmouth Hall, and when Dartmouth Hall burned down the first time, the students were all crying outside, "Save the zebra, save the zebra." They didn't care about anything else. Anyway, Dartmouth had a museum. Dartmouth had a library. Well, they didn't have any books, but President Wheelock had a big personal library of 300 books. And so Wheelock's personal library was the library of the students, and there were a few books on science and astronomy there. One of them, we have a list, one of them was this book by Durham, a famous book in natural theology. So it's astrotheology, or a demonstration of the attributes of God from a study of the heavens. And that was one of the books. This is 1767, 10th edition, and that was available for Dartmouth students. So they had a library. And then they also had a philosophical cabinet. And the philosophical cabinet was where you would teach natural philosophy by not just books now, but by doing demonstrations. So this was Ralph Gibson back in 1775, and they started to collect apparatus. And you needed to have apparatus, because that's what this was. So a telescope, we still have this telescope in the collection. This is a very famous artifact in our collection. It was acquired in London, 1795, and anytime you have an anniversary at Dartmouth in the past, when there's been an anniversary, and you want to trot out the importance of science in Dartmouth's history, you bring out this telescope. So I could show you pictures from the centennial, from the bicentennial, from the 150th anniversary, books published about science at Dartmouth, and they always have this telescope on the cover. That was part of the identity of the college. If you had a telescope look like this, it showed that you were a college in the American setting. If you didn't have a telescope, you'd be lacking something. And we have an orrery that also is very early, from 1785. And visitors would write about these things. So the earliest description we have, called the Dartmouth apparatus, comes from Ezra Stiles. Anybody know who Ezra Stiles was? He was the president of Yale and was a pretty important theologian. And he would travel around, because the way you would look for students, the fathers could bring them to your office, or you could go visit these towns and you could interview the students in the towns. So in one of his itineraries, he called them, in 1787, he came up here and he gives a description of what Dartmouth had in its apparatus. So the achromatic telescope, that's this. We have a planetarium, that's this. So some of the objects we had, he described here. He talks about our museum. So here's the arrows from the Ojeda Indians. Here's a fish hook. Here's the fossil. Here's something like a cannon, something dug up. You know, the museums are really interesting. But then note down further, he talks about he went to Harvard, and he talks about Harvard's apparatus too. So we are being compared, Dartmouth is being compared against Harvard. But that is in Stiles' mind. Okay, so Dartmouth gets these three things: a library, a museum, and philosophical apparatus, all here. And we have our first donation. And this donation I actually brought out of the collection. This is 1773 sundial. It's one of the oldest dated pieces we have in the collection. This is one of the oldest dated pieces of brass in the world. People that study brass want to take a chunk of this and look at it, and we've sort of held them off. Anyway, this is a story that's too complicated for me to tell, but the second commencement of Dartmouth was attended by a delegation from Portsmouth, because Governor Wentworth, who encouraged the college to come, he was not interested in Christianizing the Indians, he was interested in economic development. And so he brought the Pukka Sahibs from Portsmouth up to the commencement, including the Surveyor General for the British government, who was a surveyor mapping from Boston up to Prince Edward Island, a guy named Samuel Holland. And he brought Holland to the second commencement, and Holland was so impressed with this new college that he wrote to his friends back in London and commissioned a fine, fancy sundial to be made. It cost 10 guineas, and that's 10% of the salary of Dartmouth's first professor. So those of you who are professors, do the 10% of your salary, and you can figure out sort of the significance of this donation. Anyway, it's a very handsome dial, and gift of Samuel Holland, Esquire of His Majesty's Surveyor General of the lands of Northern District of North America to Dartmouth College, New Hampshire, 1773. And it's a very fine, precise dial. You can tell time to the seconds to set your watches. And indeed, this was probably the only sundial within 100 miles of this place. So if you had a pocket watch, you could bring it here and you could set it. If anybody is looking closely at this, you see that we maybe got a dial that wasn't the most carefully made, in that the compass winds are around the dial. You can come down and look at it. And here's south-southwest, and here's south-southwest. Somebody was asleep at the switch. But more importantly, I want to suggest this dial had an identity for Dartmouth that placed Dartmouth in the world, not just in the woods of New Hampshire. Around the dial, here's New Hampshire, Portsmouth, New Hampshire. Around the dial, between the hour lines, are cities. And these cities are time zones. So the first one is what's 1 hour to the east and what's 1 hour to the west of Portsmouth. What's 2 hours? And here are the cities. So if we go east, we have Martinique and Louisbourg, so down in the Caribbean and up in Canada. Then we go to Brazil, the Azores. We get to 5 hours out, we get to London. 6 hours out, we get to Copenhagen, Constantinople. 7, 8 hours, we get to St. Petersburg and Aleppo. On this dial is the globe. The other side, we go to the west, and you end up with New Zealand. So here's where the dial was. The president's house was on the corner where Reed Hall is now. And so you'd come up from the river, and the first building you would see amidst all these trees would be the president's house. And in front of the president's house, you would see this pole with this dial that gives you Portsmouth, New Hampshire, and the rest of the world. This was Dartmouth's advertising sign. This was Dartmouth's identity that, yes, we're in the woods, but look at this. We have science. We have this dial that puts us in the rest of the world. This dial had symbolic power. It was not just a sundial to tell time. It meant more than that. And for 60 years, it sat here until Reed Hall was built in 1839. Okay, so there was some science. There was very little research. The earliest evidence I found of something that we would now call research or contribution to knowledge is from President Wheelock, who was measuring the magnetic declination from true north. And here's an article published in the American Journal of Science and Arts by somebody in Western Reserve, an important astronomer, in 1838. And he's simply collecting measurements of magnetic deviation from New England. And for Dartmouth College, New Hampshire, he has President Wheelock, who measured it in 1765. The declination was 7 degrees. At the present, which was 1810, so Wheelock must have mailed this information to Loomis. It was 4 degrees, 15 minutes. Now, if you know something about magnetic declination, you know that in this amount of time, you can't change by 3 degrees. So there's actually some letters about that later, and either this is a typo, and that should be 8, or Wheelock didn't know what he was doing when he was doing the measurements. I don't have an opinion on that. The first Dartmouth professor to publish research, and I emphasize this because my point is here, these professors were teachers. They were not researchers. Dartmouth faculty did not publish research. No college professors in the United States published research. The purpose of a college was to teach and to prepare clergy and physicians and lawyers. That's what you did with colleges. You weren't doing scientific research. That's something that's going to come later. But James Dana, he's the first professor to publish. He got his AM at Harvard, MD at Harvard, and he went to London to equip Harvard's Chem Lab, but then he came here and was a lecturer in chemistry from 1816 to 1820 in both the medical school and the college, and then became professor of chemistry and mineralogy for 6 years, until he went down to Columbia and taught there chemistry. Columbia was the first medical school in the country, the oldest medical school, the most prestigious medical school, and that's where he went. A Dartmouth professor is doing some publication. This is electricity and magnetism, right after that was the phenomenon discovered in 1820, 1823. He now is doing some research on it. But he leaves Dartmouth. And that's going to be a pattern. He's not going to be the first Dartmouth professor who leaves Dartmouth. Okay, let me move to the second chapter. This is the observatory, what I call the observatory craze. Building observatories was something of the 17th, 18th, and 19th centuries. This is the first scientific infrastructure where you get a specialized building to do specialized needs that suddenly starts to spread and everybody thinks they need to have one. It started out as a state enterprise, and indeed earlier observatories were all big state enterprises. So Paris started the Paris Observatory in 1667. A decade later, Greenwich was founded. These are primarily for navigation. You need to produce Nautilus almanacs and things for your navies and your sailors and for timekeeping. But they started, this was state-funded big science, we would say. Universities started even earlier. So the first university observatory was in Leiden in 1632, and then it slowly spread. So Cambridge got one in 1707. Göttingen, Austria, Hungary, Paris, Milan, more German places here. This is now the founding of Dartmouth. So Oxford got theirs in 1772, and it continues, and then it explodes after this. Well, historians call this the observatory movement. Many of these were, again, primarily teaching facilities, but with these infrastructure and with the staff you had there, you started to get scientific astronomy research being done as well. So that's the international, sort of the global background that's going to lead Dartmouth to making its decisions. Well, Americans think about this too. The first person that we know, Marlene's smiling, to propose an observatory, she studies Jefferson, to propose an observatory in this country and actually draw things out was Jefferson. He wanted the tall tower, sort of abstract design here. This was for UVA. It was not built, but it was proposed back about the time when Dartmouth was started. So there starts to be serious discussion about building working observatories in the United States in the 1830s. This is 15 years before Dartmouth does it. So George Airy, who was the astronomer royal at Greenwich, the most famous astronomer in the world, in 1832 wrote this big paper on what he called the progress of astronomy. And it was kind of a celebration of this observatory movement. And he said that he was not aware that there was any public observatory in America. So he was sort of putting down the United States. And that was very typical. Jefferson worried about this too. So you have a new nation, and the new nation starts to look to Europe and say, oh my gosh, they're doing science over there. We aren't doing science. What can we do about that? Can we create an American science to start to compete with this European science? And here Airy is sort of saying, well, sorry, we don't have any observatories. Well, John Quincy Adams, 1838. In 1838, the country was given the big donation by somebody whose name is, I think it's Stimson. Who gave the money to found the Smithsonian? Smithson. Smithson gave this money to the federal government to do science. Now, if you read the Constitution, the federal government is not supposed to do science, right? That was something that was left to the states. So, big fight about this. States' rights. You've got the Civil War coming up in 2 decades. So what are you going to do with this money? And former President John Quincy Adams made this famous speech. It is with no feeling of pride as an American that the remark may be made that on a comparatively small territorial surface of Europe, there are existing upward of 130 of these lighthouses of the skies. Well, throughout the whole American hemisphere, there is not one. So he's bemoaning the fact that there are not observatories. Now, this word that he used, lighthouses of the skies, turned out to be ill-chosen. Everybody who didn't like this idea made fun of this. I mean, how can an observatory be a lighthouse of the sky, right? It's not making light, it wants to be dark. And the word lighthouse of the sky became, for 20 or 30 years, a kind of code word for a harebrained, silly idea. So if you said something stupid, you would say, oh, that's a lighthouse of skies idea. So he was mocked for making this kind of claim. But they're going to start. Why? Well, the competition with Europe is very important. There were, of course, practical needs. Railroads start in the 1840s. And when you have railroads, you suddenly start to need to worry about common time. And observatories can do that. You had competition among educational institutions. You had local rich people who wanted to make their town be more interesting than the next town. Cincinnati is a famous example of that. Cincinnati built a big civic observatory. It didn't belong to a university. It belonged to the rich people in town. And it was sort of like having a movie, a theater, or an orchestra, or an opera. You'd have an observatory, and you'd go entertain yourself in the evenings. There was very much popular enthusiasm for astronomy. Natural theology was very important. Everybody would, go look at the stars, and it will make you more religious. And then I put this question about research. If you look at the motivation for why to build these things, you don't see very often people saying, we want to support a research program to learn more about the structure of the universe. No, it was more of a kind of entertainment, a kind of awe, and then this competition that was there. Well, here's some numbers about the growth. We won't look at that. Here's an actual list then of the first observatories coming in the United States. And I stopped in 1848 with Dartmouth. So there's about 15 before. The first one that was called an observatory was University of North Carolina. It's a 2.5-inch telescope. So that's a tiny telescope. It's about the size of the one that I just showed here. But nonetheless, they had a building for it, and it was called an observatory. And I list here also where the instruments are made. We don't have time to look at this. But most of the early instruments are made by German opticians and German makers here. So Yale, 1830, Williams, 1834, Wesleyan, Case Western Reserve out in Ohio, a high school in Philadelphia. Here's another high school, a female academy. These are both Quaker related. The Quakers were very much interested in natural theology of the heavens, and their high schools had two of the best telescopes in the country in the 1840s. The military academy, there's some in Washington. Here's the one in Cincinnati. Harvard, 1847, Amherst, 47, Charleston, South Carolina, and then Dartmouth. And this is the size of the objective lenses. So they're all sort of, fairly small, and Dartmouth is sort of in the middle in terms of how big the apparatus are. Only one of these early telescopes was made by an American maker, Alvin Clark, in 1854. And Clark is going to be, they're down in Cambridgeport, Massachusetts, is going to be the first American optician that can make telescopes that can compete against and eventually would become better than what can be made in Europe. So this is, you have to go to Europe to get your apparatus because American makers simply can't do it. Okay, that's the context for the Dartmouth story. Dartmouth did not get its observatory because the president said he wanted one, or because the trustees said this was important. They got their observatory because what I call an entrepreneurial professor wanted to do this. And this is Ira Young. Ira Young is the person who is going to bring a new tone, a new identity to Dartmouth, and it's what I call an identity of competition. Ira Young is going to be the first faculty member who I've found who looks what's happening in other schools and said, Dartmouth, you need to do this to keep up with the Joneses. That kind of rhetoric you did not find before. That's the rhetoric now we all live in, right? But that's something new. And I'm suggesting that Shattuck and astronomy at Dartmouth is where Dartmouth, for the first time, saw itself in national or international competition as a motive. This is not just now in the pine trees of New Hampshire, but Dartmouth is getting this sense that what's happening here is bigger than the pine trees in New Hampshire, and therefore you need to measure yourself against what's happening elsewhere. And Ira Young is going to be the person to do this. Now, Ira Young is a Good Will Hunting guy. Remember that movie? When was it? In the 90s? He wasn't a janitor. He was a carpenter. Grew up in Lebanon. His dad was a carpenter. He was a carpenter, very good carpenter, and he'd work on projects at Dartmouth. And he'd hang out with the natural philosophy people, and they said, oh, this guy looks pretty good. And they brought him, and he was in the class of 1928 and did very well. And then it's very typical then, if you were good, they'd ask you to come and work with the students. And so he served as a tutor in mathematics and natural philosophy for 3 years. And then he made the crucial career move that is what you needed to do in the 19th century to become a professor. You needed to marry your professor's daughter. There are hundreds of, I used to study 19th century science. There are hundreds of examples of this. I kid you not. Especially in Germany, where you start getting crowded. Well, that's what he did. And then he became professor of mathematics and natural philosophy, and then astronomy and natural philosophy for about 20 years. And here's the key thing. He published nothing. This was not in the era where professors published, but he was an institution builder. So, he's a carpenter. His brother is Ami Young, who is a very important architect, just starting his career in the 30s. But Ami Young is going to become a national architect. And again, Marlene, who's an architectural historian, she could tell us much more about Ami Young. He designed the Custom House in Boston. He designed the State House in Montpelier. He designed for the U.S. Treasury government buildings all over the country. And he started with Dart Row. That's how he learned how to be an astronomer, to be architect. Anyway, the 30s was a time of growth for the college. Expanded in students. Dartmouth had more students than Harvard in the 30s, and more students than Princeton. Only Yale had more students than Dartmouth. Out of this growth, built Reed Hall. And who did that? Ami Young and Ira Young was like the local guy who made it happen. This was his time of optimism and of competition. So I don't have time to go through all the details, but Young and the college librarian in 1846 wrote this document to the trustees that was unparalleled. The annual budget at Dartmouth then was $12,000. And they said, we want to improve the infrastructure here and give us $16,000. Now, I don't know what the budget is of Dartmouth now. What is it? 100 million a year? So that would be like if somebody would say, I have one project in Dartmouth, I want you to give me $160 million to do it. That takes chutzpah, right? Those people said, we are going to bring a new tone. We're going to make this Dartmouth into a different place. And to do that, you have to start to spend some money and you have to think big. And that's what this observatory let them do. So he wanted not just an observatory, so most of the money was going to go to the library, right? The librarian was an older professor, so he needed $10K for the library. The observatory was going to take $4K. Then he wanted to make a magnetic observatory. This was the time when Gauss was making magnetic observatories all around the world to do sort of global magnetic studies. He wanted to do weather instruments, he wanted to do surveying, he wanted the microscope, etc. Well, what happened? They wanted $16K. The trustees gave them $2K to do this. But the trustees gave them that money. That's better than nothing. And they gave him $300 to build a shed. So he didn't get a building, but he got the apparatus. And they said that Young could visit other observatories to see how to build an observatory. What does that mean? That means Dartmouth now is measuring itself against other places. You don't just sit up here in the woods and do something, but you go see what they're doing down at Yale and what they're doing over in Wesleyan, etc. That had not happened before. This is a new identity for the college. You have to measure yourself against what's happening elsewhere. Okay, and the rhetoric of competition is right in this memo. So, let's give you some nice examples here. We are sorry to be obliged to think that no college of equal reputation, as to Dartmouth, is so imperfectly provided with books, adapted to the wants of professors. And since the standard for the sciences has been raised, and the facilities for study so increased in our literary institutions as our colleges, we cannot but suffer by comparison with other colleges. Our library is no good, and we're going to suffer because of that. Or, Young added up that Dartmouth had spent $2,300 on apparatus since it started, and then he boldly says, look at this. Amherst, Wesleyan, Williams, Princeton, and Western Reserve colleges have expended from $6,000 to $10,000 for apparatus, and all but 2 of them have gotten an observatory. Dartmouth is behind. Well, he took his $2,300 and purchased basic apparatus for an observatory. This is all from Munich. So he purchased from Merz and Sons in Munich, and they were probably the world's best telescope maker. The Quakers in Philadelphia had bought their telescopes from Merz. Bond down at Harvard had bought his telescope from Merz, and so that seemed to be the thing to do. And we have a lot of this original telescope still here. So here's the lens, the 6.4 achromat lens that was made by the people in Munich. We still have this. I decided not to bring it out because I don't want you guys to put your fingers on it. But you can come down and put your fingers on the sundial. It's very robust. The tube, we just discovered last year, it was a mahogany tube that a collector, we don't have this tube. This telescope was taken away in 1871 when we got a new telescope from the Clarks, and the tube disappeared. It turns out a collector up in Canada has this tube, and he's agreed to give it to us after he dies. So he's going to keep it, but at some point we're going to get the tube. He brought the end piece, and it turns out that his piece fits exactly on our lens. And there's calibration marks across the tube that show that it's absolutely together. So we're going to get this at some point. This is the mount. We still have the mount, a piece of the mount, and then this was a clock. You needed to have a regulator to keep good sidereal time. And this comes from Utschneider and Fraunhofer. Whoops, I misspelled the name there. And we have this apparatus all remains. So this early apparatus, things only get saved, Ralph knows about this, if they have important symbolic value. This Shattuck Observatory and this apparatus was important for the college and the people doing science. And they made sure that these things were going to be kept. And that's why we have this stuff. We have, this is not the original, but I think this is from about 1900. A ladder that was used when you look at object close to the horizon, the telescope tips up and you need to get up to see. And this ladder comes from the observatory. And this, I think, belongs in this picture. This is a very heavy weight. I'll show you later on when I show you the telescope. There was a clock drive to make the mount follow the sky. And it wasn't drawn with electricity in 1848, it was done with weights like a clock. And I think this is one of the original weights. So he would have got this from Munich in 1848 as well to drive this mechanism here. Okay, this is what the college looked like. In 1855, there is Dart Row and there is Shattuck Observatory. And that's it. There's nothing else. This building was designed, this is Reed Hall, designed by Alma Young. Thornton was designed by Alma Young. Wentworth was designed by Alma Young. And the observatory was designed by Alma Young. The backbone of the college is Alma Young's architecture. Now this building, of course, when 1848 wasn't here. So where does Young put up the telescope? The trustees gave him $300, and he says he's going to put it in a shed in his garden. Now I did not know until Tuesday where that garden was. And Barb Krieger, who works in Rauner, she is wonderful. You don't need to go to a card catalog for Barb. You just ask her and she knows where things are. And she pulled out this map, and here is Professor Young's house, and this is his garden. This is the cemetery. So this is sort of over in the parking lot behind the Tucker Foundation. That's where a building was with a slide-off roof, and that's where the telescope was put together for the first time. Now, I've worked on Shattuck for 20 years, and only last week I know now where it was. So this is where the first 5 years of the Shattuck Observatory was. Well, it wasn't Shattuck, because Shattuck was not in the picture yet. But this is where the apparatus was first set up, and then when Shattuck was built, the telescope was moved to this site. Okay, I've been emphasizing this new focus on competition. So this is the ORC from 1849-1850 that announces the new telescope. What I like is it's published by the students. The faculty didn't publish the ORC, the students published the ORC back then. And if you go to the discussion of apparatus, here's the cabinet of the apparatus. The lectures in astronomy are accompanied by celestial observations and instructions in the use of instruments. The splendid telescope obtained during the past year, ranking as the third in the United States in magnitude and power, supplies important facilities for these purposes. So here's the claim. We got a new telescope. It's the third biggest telescope in the United States. Now they counted wrong. It's about the seventh biggest. But, who cares? The point is, you would never see rhetoric like this before in the ORC. We want to be up there. Dartmouth wants to be up there with people that are doing serious astronomy. And we've got the apparatus now to do it. Well, you go to 5253, and there's a big technical discussion of the various apparatus here. And there they compare it to the refractors at Cambridge. They don't mention the word Harvard. And then the Cincinnati Observatory. So again, they're focusing on big observatories, and Dartmouth wants to be a player with those people. There is only one observing notebook that I've found in archives from Ira Young. He's going to die in 1858. So he's got 10 years with the telescope. And there's only one notebook that's there. It's Transit Observations, 1850-51, which is sort of how to just do your basic alignments to get the north-south alignment right with your apparatus. And it's got two students who worked on it, and then Young's son, Charles Young, who's going to come in the story later. And they were all then taking this. I've not actually technically looked at this data, but I want to go through it to see exactly what they were doing. But that's the only thing we have from this early period that shows using the telescope to actually measure things and to take quantitative data. Okay, well, how do you get a building? So they wanted to, the trustees didn't give them enough money to build a building. So Young, the entrepreneur, what's he do? He goes looks for a private patron. Again, this is, the way you standard to do things. And he went to George Shattuck. Shattuck was a member of the class of 04, then got his medical degree down at Penn, became a very important Boston physician, and gave Harvard a lot of money to endow professorships. So he had a reputation of being a philanthropist. And Young writes in this letter. I can't quite tell if Young had met Shattuck before. It's a pretty formal letter. So this might be something thrown cold over the transom to Shattuck. And says, the college tried to get money for an observatory. They weren't able to do it. Mentioned the competition. Dartmouth's falling behind Amherst and Williams. Didn't say anything about Harvard. And he sent this sketch. And this is the earliest picture that we have. This is from 1852 of what Ira Young's ideas were for what the observatory is going to look like. So here's the dome. And then it's got these north-south buildings and here, that extend out, arms. And here's the going out to the east where the transit telescopes are. This is pretty much the floor plan that Shattuck is built on. And that was in a letter to the trustees here. So he said, what can you do to help us? And Shattuck writes back and he says, okay, Shattuck was a clever guy. I'll give you $9,000 but the trustees have to kick in another $4,000. He wanted the college to belly up as well. He said Young should visit Europe to go look at other observatories, not just now down to Philadelphia, but should go, if we're going to play in the big time, should go visit the European observatories. Young should build the building, and you needed to have a big library. It was important to have a library. So what do? Well, Young takes his son Charles, and they go to Europe in 1853. I don't have time to talk about the details, but the working observatory then is going to open in 1854. Here is Charles Young's diary. He had just graduated in the class of 53, and he went with his father. He was 18 years old. And we have a 100-page diary of Charles Young, who's going to become, I still make the claim, Dartmouth's most famous scientist ever is Charles Young. And we have his diary here. What's interesting about the diary is very little about science or about instrument making. It's about culture. So he's interested in women's fashion. He's interested in art museums. He's interested in music. So here he's in Munich, and he goes to the Glyptothek, which is the gallery of Greek sculpture. And he has a whole page here talking about the Greek sculpture that is here. They had a letter of introduction to these various and they met all the leading astronomers of Europe. And they had a letter of introduction from Benjamin Sullivan. Benjamin Sullivan was a chemist at Yale. He was the founder of the American Journal of Science. He was probably the most well-known internationally American scientist that we had in the 1830s. And these guys got a letter from him of introduction. That had never happened before. A Dartmouth professor to write to somebody at Yale and say, give me a letter of introduction. Ira Young, this entrepreneur, he saw himself as wanting to join world science and to take Dartmouth into this step. And he drugged the trustees along to make this happen. Okay, so this is what it looked like. This is the new telescope now from the Clarks. We don't have any photographs of the original Mertz telescope. But what's interesting here is the dome. The dome was made out of wood completely, covered with tin, and they got a shipbuilder to make this. Shipbuilders know how to make curved things out of wood, and for many years, the dome, people talked more about the dome than they did the telescope. And after, well, I'll come back to the dome story later. Anyway, then it was published. Loomis published a book on observatories in 1856, and this was the first picture. So the observatory then was presented to the world. Dartmouth was now in the observatory movement. Okay, chapter 4. The height of Shattuck's importance when it was doing active research. And again, I could give 2 full colloquia on just this, so this is going to be really summarized here. So this is the son, Charles Young, who I claim would have gotten a Nobel Prize if they'd been giving Nobel Prizes in the 1870s and the 1880s. He did absolutely fundamental work at the beginning of astrophysics. You know, when you suddenly get spectroscopy in the 1860s, and you can now start to learn all kinds of things about the physics and chemistry of these points of light out in space with this new apparatus. The first generation is going to get a lot of the low-hanging fruit. And Charles Young did that with the sun. So he's really an important person. It's not an accident that he was concerned about those museums in Europe. Class of 53, then he thought he was going to be a clergyman. And so he went and studied at Andover Seminary for a year. Very good in Greek. He came back to Phillips Exeter Academy, Andover Academy, and taught for 2 years there, teaching Greek and Latin. Not astronomy or mathematics. And then he went to Western Reserve, where Loomis was, for 10 years, and then was brought back to Dartmouth and spent 10 years here. And then went down to Princeton as the director of the Halstead Observatory and was at Princeton for the rest of his career. I'll say more about that transition later. He published 39 articles in the time that he was here, so in 11 years. Again, unparalleled. Dartmouth professor didn't publish anything. And now here he's publishing at the same rate of a J.J. Thomson or William Thomson or a Helmholtz. I mean, he's now working at European productivity there. And he wrote this textbook called The Sun that there are 19 editions of in 4 languages. Here's examples of some of these. This was a global textbook that he wrote. So just, there had been no other Dartmouth professor like that before. And if you look at other colleges in the United States, they had no professors like this before. He was working at a European level, European Research University level, but he was at Dartmouth College. Note that the first PhD in the United States was given at Yale in 1861. So this is, you know, the idea of how we understand research now and doing PhDs, that's coming later. But Young is very productive. So he worked on the sun. This is some of the spectroscopes that he commissioned from the Clarks. We still have both of these, again saved because of the importance of his work here. He became sort of famous globally in 1869 when there was a total eclipse of the sun, and he went with some major American scientists and Maria Mitchell. She was I think the only woman astronomer at an American college or university at this time. She was at Vassar. And she was there. This is our little telescope, the one from 1785. They took that along, and she's using that. And this is Charles Young here with the Dartmouth telescope, and they are going to discover in the corona, which is this big atmosphere that you can only see in a total solar eclipse. He discovered some lines, some spectral lines there that you could not find in the lab. And for 50 or 60 years, it was felt that this might be a new element, that there was something in the sun that was not on the Earth, and it was called coronium for a while. It turns out it was iron, heavily ionized iron. The corona is what, 2 million degrees or something like that? It's super hot, and so you're going to get big ionized states of the atoms there. Anyway, so it wasn't a new element, but nonetheless, this caught worldwide attention, and this put Dartmouth on the map in astronomy. The next year, in Spain, he saw another solar eclipse, and there he discovered the flash spectrum, which is I don't have time to go into the details. They were basically trying to sort out what are the levels of the atmosphere in the sun. And one of those levels during an eclipse moves from dark lines, absorption lines, to emission lines for 2 or 3 seconds. And he discovered that for the first time. He's studying the spectra of sunspots, the chromosphere, prominences. He took, from the Shattuck Observatory, he was the first to try to take a photograph of a solar prominence. That's this big sort of jet that jumps up from the surface of the sun, and you look at the limb of the sun that's supposed to be, an arc, and you see then this huge jet of gas pumping out. And he tried to take a photograph of that using a wet plate. Took 4 seconds, so you're not going to get much detail, but nonetheless, he did this. He was the first to correlate magnetic storms on the Earth with storms in the sun. So the work that's done here in solar weather, it's appropriate in that Young was the first person to say there's a connection between these big solar flares and what happens on the Earth. He was the first person to use a diffraction grating to do solar physics as opposed to prisms. For the physics people, you understand that. The other people can't explain it. Okay, 1877. Young wants to build a bigger observatory. He says, Shattuck's too small. I need a bigger telescope. And Princeton said, we'll build you a bigger telescope. And the trustees at Dartmouth said, we'll give you $5,000. And Young decided to leave and went to Princeton. And this is what the students, wrote about this. Very interesting in terms of this rhetoric of Dartmouth's identity. Princeton has made Professor Young a very flattering offer. Usually, the student newspaper doesn't talk about hiring of professors, right? It is not strange that any college should wish to obtain the first scientist in America. The students saw Young as the most important scientist in America. With the means at their command, they, Princeton, can offer such a man as Professor Young a far better inducements than Dartmouth can at present. Neither can we, in the least, blame the professor for accepting them. We are sorry to say that both he and the science which he is doing so much to advance will undoubtedly be gainers by the change. So the students are very magnanimous. It's going to be good for science. It's going to be good for Young. The reputation that has attached to the Dartmouth Observatory will be translated to Princeton. And it will be increased proportionally to their increased facilities. We wish to assure Professor Young that he will carry with him the goodwill and the profound gratitude of all of our students. That's very nice sort of rhetoric to get from the students as they are losing their beloved professor. Okay, I don't have time to go through the details here, but this decision, I think, is a very important decision that was made. It's important for Princeton, and it's important for Dartmouth. It shows that Dartmouth was saying there are limits to the amount of money it was going to spend to support the infrastructure of doing science. And Princeton was saying it was ready to open the spigot. And indeed, in a decade or so, Princeton becomes a university. And Princeton has remained small, but Princeton has won Nobel Prizes in the sciences. Dartmouth has remained small, it's been a college, and Dartmouth, to the best of my knowledge, has not won a Nobel Prize in the sciences. Princeton made some decisions in the 1870s and the 1880s that Dartmouth did not make. And it's reflected in this story, and that has shaped both colleges, both universities, up until the present. Now, I would have much more to say about that, but I don't have time to unpack it. Okay, the other person who's very important is E.B. Frost. For 10 years after Young left, there was nobody in charge of the observatory. Then Frost is here. He was a boyhood friend of Young's son. They grew up together in Hanover. His dad was a professor at the Dartmouth Medical School. He was class of '86. Then, just as Young, he stayed on as a professor, an instructor in astronomy. He went to Germany for 2 years. No, he never got a PhD. Then he came back and was, for 6 years, was professor here of astronomy and the director of the observatory. He published, again, working on the sun, prominences, he worked on sunspots. He published some important papers about a comet. And just at lunch today, I was talking with one of the graduate students, and maybe he also made some observations of a supernova in 1895 that now Rob Feason and, where are you? Oh, there. What's your name?
Katie.
And Katie are working on. And I need to go see if I can track that down. I didn't know about that. Anyway, he published 23 papers. Here's one of them on solar observations of sunspots. And note here he says in the paper that some of the observations are made by students of the college. Now, that's very rare to find that in a paper from the 1880s and 1890s. A published paper, and the students are engaged in helping doing this, and that's what he did. Well, he went out to the dedication in 1897 of the Yerkes Observatory, which is Chicago's observatory, and caught George Ellery Hale's eye. He wrote the report about this in Science magazine, and wouldn't you know it, in 1898, Hale brings him out to become the director of the Yerkes Observatory, which was the biggest telescope in the world at that time. Young leaves to go to Princeton, Frost leaves to go to Yerkes, and becomes a very important player in American astrophysics, the first generation American astrophysics. I don't have time to go into his story again. Anyway, another important Dartmouth professor does some important work here and then leaves. Well, he also taught here, and I'll let you read this. He has in his autobiography a nice study of he would require his students to come at 2 o'clock in the morning to do observations. And they would decide to bring the whole campus. So they would go through the dormitories and wake everybody up and make them all march over here. And then they would, sort of military fashion, all go and look through the Shattuck telescope there. It's just, people liked him. He was interesting. But Shattuck is down in the river valley. And in the 1880s and 1890s, astronomers finally realized that the future's in the mountains, not in valleys. So the Lick Observatory out of Mount Hamilton is the first mountaintop telescope that was opened. Look at that number. So Young wanted $25,000 to build a telescope here. But to build something on a mountain is almost $1 million. So the future of observatories that are in cities and in the East Coast, at Princeton or here, in terms of doing science, that future is not going to look very good. So what are you going to do with Shattuck then? Well, my chapter 5 will just be sort of a quick overview of the last century to see what kind of ideas people have had for what this institution could be now that the place where you would go do serious astronomy is going to be, observational astronomy, is going to be up on mountaintops, not behind Wilder Hall. So the next director was a guy named John Poor, who was class of '97. These dates are probably right. So then, again, no PhD, but became the professor of astronomy and the director for almost 30 years, then up to 33. He published 2 papers. So again, he's not publishing. This is back to the traditional pattern, like all the other Dartmouth professors. You don't publish, you teach when you're here. But he updated the observatory. So he rebuilt the mount, he got a new tube, he took out the weights and put in an electric motor that we still have. He has the apparatus that's in Shattuck Observatory now, in terms of what's in the dome up there. It was made in 1906. And he got this new photographic corrector lens, another lens that you add if you're going to primarily make photographs rather than use the eye. It turns out you want to go more toward the purple end of the spectrum. If you're taking photographs, you want to go toward more the yellow end if you're using the eye. And so he had to change the thing as if he was going to do photography as a program, but he never published anything there. He was teaching. So here's a course in ORC 1911. Spherical astronomy will be covered before studying the theory of instruments as a preparation for using the sextant, the transit, the equatorial, and the zenith telescope. Students will be given practice in reducing their observations. He taught that course for years. So the apparatus was being used, not for doing research, but for doing teaching. Here's his upgrades. This is what the telescope looks like now. This is what the lens looked like before I took it out to be cleaned. And this is his photographic corrector that we have in the collection. that was meant to go as the second element here if you were going to take photographs. The next director was Richard Goddard. Again, a fascinating person, Dartmouth class of 20. Everybody I've talked about so far went to Dartmouth and then became a professor here. That was the pattern that you used in American colleges up until the 1950s, let's say. He was an instructor. He went down to Yale and got a master's degree. He had no PhD. And he was here again for about 30 years. No publications. But he dreamed big. So in 39, he came up with this idea, and this is what Allison found. And we haven't done enough work to see what other documents there are, sort of what he wanted to do with this building. But he wanted to double or triple the size of the observatory by building this big building to the south for Department of Astronomy. The question is whether we can find some documents. All we found is this picture. We don't have any documents describing what he wanted to do. He also taught this course on observational astronomy. He got a new dome installed. Turns out the dome was leaking, and so he wanted to preserve this. So this is the old dome. There was a big debate about whether this would go to the Smithsonian. The Smithsonian said that they wanted our dome to document this observatory movement, because there were only 3 or 4, by the 50s, there were only 3 or 4 of these early observatories still extant. And so the Smithsonian said, we'd like to document this. It turns out it went to some place in Connecticut. The Smithsonian didn't take it. This is the new dome that's being built there. So here the Smithsonian said they want to document this endeavor to illustrate the heroic age of American astronomy with Dartmouth's dome. Well, Goddard was basically a navigation guy. He'd done Arctic exploration, worked for the Carnegie Institution, and he was more comfortable teaching navigation for basically kids that grew up on yachts than he was teaching astronomy. And so here he got some money from the National Science Foundation to build this flat deck. It's not there anymore. But sort of where the parking lot is now, behind Shattuck, that was a big wooden deck in the 60s and the 50s where they would do these navigation exercises there. So here, the idea was to turn Shattuck into a navigation place. My last dream brings us up to 1972, and D. Mook, who was a professor here until the 90s. Maybe some of the more senior people in the department will remember D. Mook. He came in 1970, was an observational astronomer, and I did not know this. Again, this is a document I found just last week, where he put together, President Kemeny came and visited the observatory. Apparently there were issues with light pollution, speaking of the next week's colloquium, and trees. And so the astronomers wanted to cut down the trees. And President Kemeny said, ooh, I think we maybe better study that before we start cutting down the trees. That's a hint to the current administration. So Kemeny commissioned this position paper on observational astrophysics at Dartmouth College, Plans for the Future. It's a 20-page document written by D. Mook and Forrest Bowley, who was a generation before. Maybe a few of you remember him. He did astronomy as well. Basically, they said the problem was that undergraduates could not get time at the big observatories that the faculty were working at. So at Kitt Peak or Saratoga, that's where D. Mook worked, they wouldn't let undergraduates go to observe. So the question was, could one build a telescope that would let undergraduates learn, sort of the electronic apparatus that you needed to do observations here, rather than to go to the mountains. Then they had listed all the problems, and here they had in the document, cutting the trees would create a major emotional impact among the older students, faculty, and other members of the college community who have come to love the grove of, what must that be? Woods, probably, it's woods. The grove of woods atop the hill. My spell corrector is going crazy here. Anyway, so D. Mook and company realized that there's more to this space back here than just an observatory. And they said we need to worry about it. So what's the idea? Keep Shattuck and go find a mountain in New Hampshire and build an observatory there. And guess where they wanted to go? Rennie Farm. Those of you who laugh know the joke. I won't say anything more about it. If they'd done this, maybe the college now would have saved millions and millions and millions of dollars. Anyway, it has an altitude of 1,200 feet, and they only needed $250,000 to do this. And this is what they wanted. They wanted to put up 3 domes and then have a dark room for photography, an office, a laboratory, and a living area so that somebody could actually live there. Now, I haven't had time to track down what happened to this proposal. I think nothing happened to this proposal. This is 72. Remember the Sherman Fairchild Tower? That went up in 74. So I'm guessing that whatever loose cash Kemeny had for science went into that tower rather than this. But that's something that Allison and I need to dig out of the trustees' records. The trustees' records are closed for this time, and so it's hard. You have to get permission from the president, and it's a little tricky to see some of this stuff. Okay, they described what Shattuck had, and I was amazed. DMOOC had put in the apparatus that you needed, that you were using on big mountains here in Shattuck. So they had a PDP-8 mini computer there to do data analysis. I used a PDP-8 when I was an undergraduate, way back in the 70s. They had a photometer with digital output. They had an astronomical spectrograph that was on the refractor. They had a dual-channel photochemical polarimeter to do stellar spectroscopy. This is state-of-the-art stuff that you would use on a big telescope. They were using it here. And then they had this photomultiplier system that they said in the report allows the 9.4-inch to photograph galaxies and clusters in the same time it takes for a 50-inch telescope. So he was giving these undergraduates experience of the electronics you need to do observational astronomy here in the little Shattuck Observatory. I did not know that. That's amazing. That's the last time that there was sort of serious electronics done there. Okay, finally, just to wrap this up, another thing that I was surprised to learn, many of you again know something about the history of the college, is that in 1964, the trustees decided to expand graduate education. And that's when the physics department started to offer PhDs, was 1964. And my assumption was, okay, before that time, there was no graduate work done at all. So, this question about doing research was not very important. But then you start to look, and it turns out that there were people doing master's degrees in physics all the way from 1900 on. And it's a goodly number. I mean, I've not added them up, but that's 100 theses that are over in the archives. So there was research being done. Now what I want to do is take these names and see if any of them ever published. In other words, did any of these people become scientists? I don't think so. I think most of these are people that were TAs. So you would need somebody to help run the labs, and they would take a good Dartmouth student, undergraduate, and then keep them on for another couple of years, and have them do a master's degree, and have them teach, is I think what the context was. Note that the mathematics department did not do this. There are no master's theses in mathematics, and there were none in astronomy. Only physics. And indeed, when they wrote the document, the position paper in '64, to suggest that there be graduate programs, they referred to physics as saying physics has the biggest profile already in graduate research. So this is the first thesis, 1904, by somebody named Julius Austin Brown, who is not going to become a scientist, but he goes to become dean of the American University in Beirut. So he's an important educator, but didn't do science anymore. It's on the reflection coefficient of glass-silver mirrors. This was related to the pressure of light experiment. So he was helping on the pressure of light experiment, and they needed to know about the reflectivity of mirrors in that, and that's where the thesis, it's a handwritten thesis. The first astronomy PhD that I could find is 1974. So this is after the PhD programs then start. DMOOC is the chair of the committee, and it's doing, big time science. The optical spectrum of Scorpio X1, this is the first X-ray source. It was discovered in 1962. Optically, it was discovered in 1966. And I think that he went to Sertololo to get the data, the observational data here for this. So yeah, you may be right. There's John Walsh there, Forrest Bowley, and James Hornig was the director of graduate studies then. So the point is that it's been only since the 70s that there has been PhD work being done in astronomy here. So the whole Shattuck Observatory was before PhDs. Okay, final dream is Shattuck on Dart Row. So here's the back of Dart Row. We're used to seeing Dart Row from the front, where you see the 4 buildings. If you look from the back, you can see the 5 buildings. My point is that Shattuck, designed by Ami Young, should be considered part of Dart Row. So taking down Shattuck is like taking down Reed Hall. That's the note toward the people who are making decisions. Anyway, so here you see Shattuck, and here is Wentworth and Dartmouth and Thornton, and then there's Reed. Now what's interesting is that I found a quote from President Lord when Shattuck was being built in '54. He was reporting to the trustees about the progress of the building, and he says, not surprisingly, it seems to be probable that the expenses will exceed the estimates, so it's going to be cost overruns, but it will be well adapted to its proposed ends and will doubtless prove in a high degree ornamental and useful to the college. So he understood at the time that buildings like Shattuck are not just about science. They're also about identity. And they're about how an institution understands itself. That's where the ornamentation comes in. Okay, so this is what I've tried to persuade you, that for these colleges in the woods, science became a marker of identity for how a college would distinguish itself and understand itself. that astronomy in the 19th century had this competition, this observatory movement, and it was entrepreneurial professors here, not trustees, who built this observatory. And again, the lack of support from the college is going to drive the best astronomers elsewhere. Young goes to Princeton, Frost goes out to your east. And I want to suggest that Shattuck was the first dedicated site on this campus for hands-on research with students. In terms of practical instruction, this was the first building. Chemistry is going to come later. Earth science is going to come later. Physics labs, this building was 1898. Shattuck in 54, 55. That's the first building where you get hands-on practical instruction, and it's continued that role up to the present. And indeed, I would say that Shattuck has been ornamental to the college. It became part of this college park. I can't tell you the Lone Pine story, but the Lone Pine was right beside Shattuck, and that has all kinds of mythic connections to Dartmouth students in the past. And I am told, and I can't look at any particular person, that there's a secret society to this day that has a key to Shattuck, and they hold their meetings in Shattuck. So that there's things going on having nothing to do with astronomy in that building to this day. Buildings get used in many ways that administrators don't always understand. Okay, so just this is some bibliography. If you're interested, I can send this to you. I'd especially again like to thank the Rauner staff and Barb Krieger and Peter Carini, and then Allison for her wonderful work in the archives. All of this stuff had to be dug out of the archives to put this story together. Thank you very much.
For a wonderful talk. Do we have questions?
Roger.
Comment, I were young, might have had a connection with Benjamin Sullivan. He talked about his colleague in chemistry, Oliver Pacer Hubbard,
Yes.
was the son-in-law of Sullivan. And in fact, Hubbard, if I remember correctly, while Young was in Europe with his son, was supervising the construction
Right.
of the observatory.
Now, there are other connections to Silliman. I guess I'll tell this story. The beginning of the petroleum industry was going to start at Dartmouth. So there are Dartmouth students, like class of 1856, who are from western Pennsylvania. And there's this stuff coming out of the ground, and the black stuff. And they put it in a bottle, and they bring it here and give it to Professor Crosby, who's the chemist here. And they say, what is this? And he analyzed it and said, this is, a product that could be used for doing heating and lighting and stuff like this. It has important products that you could use, and wrote this report. And they tried to take this report down to New York and raise money to start to explore, and they couldn't get any money. And so they took the bottle to Benjamin Sullivan at Yale, and he wrote them a 10-page report. And with that report, they raised $100,000 on Wall Street and drilled the first oil well in the world, and that was the beginning of the petroleum industry. So Yale and Dartmouth and chemistry and big money, it goes back to the 1850s.
Any other questions? All right. Well, Rich is around fairly often, so if
Yes,
you have
indeed.
any other questions, he's an easy person to find. But I'd just like to, can we all please say thank you again for a wonderful.
Thank you.